So hey guys, welcome back. So we were doing the chapter metals and non-metals in our foundation batch, right? So I hope you all are doing well, you are studying hard and also doing your project work and everything, right? So with this I would like to start with the topic, that is conversion of enriched ores. In the previous sessions we have seen the enrichment of ore. So we have seen there are 5 methods, right? And all the 5 methods I have discussed with you, okay, in detail, right? So what is leaching, that also I have cleared you. In the regular class I was like I said you that here it is not required, but in the foundation batch it is required. So in this I have cleared you the leaching also in the earlier session. So after enrichment, once the enrichment is done, that is the removal of unwanted impurities, okay, or unwanted substances, that is the gang particles. Now it's time to convert this enriched ore into a oxide. So what we'll be doing, the next topic is your conversion of the enriched ore of the enriched ore into the oxide of metal. So we have seen in the uh, must to be known term, that is roasting and calcination, about roasting and calcination, that we convert some sulphide and carbonate ore with the help of these two methods, that is calcination and roasting, that is heating in presence or absence of oxygen. Okay, so now let's start with the definition of this step, that is conversion, and also the examples along with it. So what exactly it is, see, we know that oxide banana is easy. We already have seen calcination and roasting for carbonates and sulfide ores. Hence the concentrated ores is converted into the oxide of metal, which is then reduced to metal. So इस step में we are making oxide, and after this we do reduction. So what we do, so in this process basically conversion to oxide is done by the process of calcination or roasting. किसका, तो सल्फाइड और कार्बोनेट ओर का. वी हैव सीन ऑल दीज थिंग्स अर्लियर ऑल्सो. ठीक है, तो इट इज़ हीटेड स्ट्रांगली इन द एब्सेंस ऑफ एयर, तो कैल्सिनेशन, in the presence of air to roasting. That is it, what we have to know. So let's write it point wise. So after enrichment of ore, it is converted to metal oxide by the process called calcination or roasting. ठीक है, calcination or roasting. So of only here we are using sulphide and carbonate ores, right? So roasting and calcination तो कर देते हैं, then after which it becomes easy to reduce the metal oxide. ठीक है, so this is what we are doing. Fine. So basically what we are saying कि calcination or roasting. Now in this process the ore is heated now at a very strongly at a very high temperature, very strongly it is heated in the absence of air. So due to which the obvious सी बात है, मतलब always you have to remember कि the temperature below its melting point we have to heat, उसके melting point से above नहीं जाना है, ठीक है. So that volatile impurities are driven off. जितने भी इम्प्योरिटीज़ होंगे वोलाटाइल, वोलाटाइल मतलब जो आप अपने आप ही निकल जाएं, वो आसानी से निकल जाएंगे. तो वी हैव टू रिमेंबर दिस थिंग, ठीक है. सो हीटिंग इज डन by keeping the temperature slightly below its melting point, so that volatile impurities volatile impurities are driven off. So this is the main purpose. So heating करो लेकिन melting point से less temperature पे. Clear? Now if you know this, ठीक है, if you know these points, then what you need to do is you need to take some examples. Now we'll take example over here, right? The first example I can take over here is oxide ore calcined, for those which are calcined to remove the moisture and other volatile impurities. So they are Al2O3 dot H2O. See, already there is presence of oxygen, so there is no need to use the oxygen. Okay, so this is done in absence of oxygen, so that the volatile impurities and excess water molecule can be removed right out of this ore. So you get alumina. Okay. Now then we have carbonate ores. Now for carbonate ores also what we do, for example calcium carbonate. Okay. So what we do, we just heat it. There is a presence of oxygen, so already in the compound there is oxygen, so there is no need to add more oxygen. So this heating will be done in absence of oxygen. Okay. So it will be forming calcium oxide and carbon dioxide. Clear? Okay. Acha, along with this there can be other impurities also, right? So for them also we can just do the same thing. Okay. So calcium carbonate Mg carbonate, that is calcium carbonate plus not plus, it is along with it in the form of crystal magnesium carbonate. They are together. To this also when we heat, we get calcium oxide plus magnesium oxide plus carbon dioxide. This is a volatile impurity, it can be removed. Okay. In the same way you have zinc carbonate, which this is also known as calamine ore, which can be heated strongly in the absence of air to produce zinc oxide and carbon dioxide. Definitely जब carbonate ore होगा तो metal oxide और carbon dioxide बनेगा. ठीक है. Then you have cupric carbonate, copper carbonate. तो we have CuCO3 dot CuOH, right? So to this also we can say on heating it is going to release 2CuO, ठीक है, plus H2O plus CO2 will be released out of this. So basically this is what is happening. Fine. So there was a mistake. Fine. Now this is what is basically happening. So to this or in this way calcination is done just to remove the excess water, volatile impurities such as carbon dioxide, etc. That is heating in the absence of oxygen, and that too at a temperature just below the melting point. Getting it? So this is what we do. So these are the different examples you can make note of. Okay. Now what about the sulphide ores? ये तो हो गए कार्बोनेट ओर के. तो कार्बोनेट ओर को we have done calcination ना, oxide and carbonate ore को we do calcination. So what about the sulphide ores? So for sulphide ores we can do what? We can do the roasting. Yes, fine. So we'll write for sulphide ores. Sulphide ores are usually converted to oxides by roasting. So for roasting we need plenty of oxygen. Okay, why so? Let's see. I'll just write the heading and give you many examples for this same. Okay, roasting. So as the sulphide ores do not contain oxygen in it, we need to provide them the oxygen. So zinc sulphide is also known as zinc blend. Okay, it do not contain oxygen. So that means to convert this into zinc oxide we need oxygen. So we'll take oxygen over here. Okay, so when we take oxygen over here and heat it, then we get zinc oxide. Zinc oxide and the volatile impurity sulfur dioxide. Is it visible? No. Sulfur dioxide. So we get this. So roasting is used when there is no oxygen present in the ore. So what we do, we provide oxygen so that this oxygen can help in the formation of the metal oxide, right? Okay, so this was known as zinc blend. Then there is Glena, then Cinnabar, then iron pyrite. All these examples has to be seen here itself. Okay, so let's see the next example. So the next example over here will be your, I think first is done, right? Second will be your Glena. Okay, so what is Glena? So basically lead sulphide is known as Glena, and it is converted to lead oxide, which is also known as litharge by roasting. So we'll write here कि Glena on heating with oxygen, will give you litharge or lead oxide. I hope it is visible till the end. Yes, and the sulfur dioxide is released. See guys, sulfur dioxide is again a very good pollutant, ठीक है, but still mining industries में से ये काफ़ी निकलता है, and we cannot avoid it as it is the necessity of today's life. We can't help it, right? Anyway, so this is known as litharge. ठीक है. Now next is your Cinnabar. Cinnabar, what do you mean by Cinnabar? Cinnabar is the ore of mercury, that is mercury sulphide. So mercury sulphide is an ore which is also known as Cinnabar. ठीक है. Now this also contains no oxygen in it, so we'll be adding oxygen to it. ठीक है. So by adding oxygen we will get mercury directly and sulfur dioxide will be removed. Clear? Then also we have iron pyrite. Okay, so iron pyrite is nothing but FeS2. Okay, so the fourth one is iron pyrite, that is FeS2. Okay, and it is heated in presence of oxygen as there is no excess oxygen with it. So I'm also writing the balanced equation, right? So this is your 11 oxygen, okay, and it will be converted to 2 Fe2O3 plus 8 SO2. Okay, so finally we have seen so many examples of conversion. So the both the calcination and roasting produce metal oxide, and in further process, that is the next step where it is said as extraction. In that all this metal oxide is basically reduced to get the pure metal. So that means these two things, that is calcination and roasting, is also a very important step in between enrichment and extraction, because metal oxide is easier to remove, metal oxide is easier to reduce, right? So that is why. So this is a intermediary step, you can say. So what are the differences between the calcination and roasting? Hardly two difference. Let's write it here itself so that it will be very very clear to you guys. Okay, calcination and roasting. Fine. So what is calcination? So basically ore is heated in absence of air. This is the first thing, right? Ore is heated in absence of air. Okay? Whereas in this case, in roasting, ore is heated in presence or sufficient supply or excess supply of, in presence of air. ठीक है? Then कहाँ कहाँ यूज़ होता है? तो it is used for specifically the oxide or the carbonate ores. Oxide or carbonate ores. ठीक है? We have seen many examples of it. We have seen the example of alumina, we have seen the calcium carbonate, then we have seen zinc carbonate, that is calamine, and so on. So we have seen the example कि कहाँ पे ये यूज़ हो रहा है calcination. तो calcination यूज़ हो रहा है into oxide and the your carbonate ores, right? So this is what is calcination is. Then is your roasting. So roasting में you have you can only use it in sulphide ore. So it is used for sulphide ores. Okay, so finally we are done with this. So now one very important point to be noted, okay, what about the chloride ores, right? So basically what happens is the chloride ores remains unchanged by calcination or roasting. This you should remember. Roasting. ठीक है? So the other three, that is basically we have seen 6 type of ore, but we need only these 4 to be discussed. So oxide and carbonate ore can be done with the calcination. The roasting is done for sulphide ores, okay, and then the chloride ores basically are unchanged with the calcination or roasting. So these are the differences and many examples I have given you. So go through these examples along with the differences and the point to be noted. Okay, so this is, with this we complete the topic, that is conversion. So in conversion you need to remember only 2 things, that is calcination and roasting. कैल्सिनेशन भी हीटिंग है और रोस्टिंग में भी हीटिंग हो रहा है, बस फ़र्क है प्रेजेंस और एब्सेंस ऑफ एयर का, ठीक है। और कौन से और हम कैल्सिनेशन के लिए लेंगे, तो वो और जिनमें ऑक्सीजन है ना, उसी को लेंगे। और रोस्टिंग कौन से लेंगे, जिनमें ऑक्सीजन नहीं है तो हम उसमें ऑक्सीजन ऐड करेंगे प्रेजेंस ऑफ ऑक्सीजन के लिए करके, ठीक है। सो दीज ऑल थिंग्स हैज़ टू बी डन. So after this there will be the process of extraction, and that is also not too lengthy, okay. We'll see some reducing agent and some examples, and then after we'll go through the refining process. So there will be electrolytic reduction, there will be other reduction processes. So this has to be done in extraction, okay. In extraction what we do reduction, and post extraction we'll be doing refining, and after that we'll be doing some very common examples like iron ka extraction, aluminium ka extraction. In regular classes we have not seen so much, but definitely in this we'll be seeing a lot, okay. So I hope you are clear with all the topics up till now. If you have any doubt regarding your subject, you can definitely ask me, and I'll definitely answer you. So feel free to ask any doubt regarding the subject. So with this I would like to take your leave. Take care, bye bye, and also meet in the next session. Till then, bye bye.